Hello everyone, I am Mrs. Sayyeda Fahmina from Ahmad bin Majid Private School. In this video, I will discuss the remaining outcomes of Chapter 10 Halogenoalkane Objective 1. At the end of this video, learners should be able to describe the following nucleophilic substitution reaction of bromoethane: formation of nitriles, formation of primary amines by the reaction of ammonia. Describe the important terminologies used, reactivity of bromoethane versus other halogenoalkanes, and apply their knowledge to answer some questions. What is nucleophilic substitution reaction? And why nucleophilic substitution reaction happens in halogenoalkane? Halogenoalkane, also known as haloalkane or alkyl halides, are compounds containing halogen atoms, fluorine, chlorine, bromine or iodine, joined to one or more carbon atoms in a chain. The interesting thing about these compounds is the carbon-halogen bond. And all the nucleophilic substitution reactions of the halogenoalkanes involve breaking that bond. The most important point is the polarity of carbon-halogen bond. With the exception of iodine, all the halogens are more electronegative than carbon. As you can see the values, carbon is 2.5, chlorine is 4. Carbon is 2.5, chlorine is 3. Carbon is 2.5, fluorine is 4. Carbon is 2.5, bromine is 2.8. Carbon is 2.5 and iodine is 2.5. That's why, with the exception of iodine, all the halogens are more electronegative than carbon. That means that the electrons pair in carbon-halogen bond will be dragged towards the halogen end, leaving the halogen slightly negative and the carbon slightly positive, except in carbon-iodine case. Let's start another reaction after hydrolysis that we already discussed in the previous video. Formation of nitriles. The halogenoalkane is heated under reflux with a solution of sodium or potassium cyanide in ethanol. The halogen is replaced by a CN group, cyanide group, and a nitrile is produced. Heating under reflux means heating with a condenser placed vertically in the flask to prevent loss of volatile substances from the mixture. Volatile means easily evaporate. The solvent is important. If water is present, you tend to get substitution reaction by OH instead of CN. So be careful, your reagent should be dissolved in ethanol, not in water. Reagent sodium or potassium cyanide dissolved in ethanol. Condition: heat under reflux. Reactant: bromoethane. Organic product: propane nitrile. For example, conversion of bromoethane to propane nitrile. Full version, full equation: bromoethane react with potassium cyanide, dissolve in ethanol, to produce propane nitrile and potassium bromide. Ionic equation: bromoethane react with cyanide ion. So what is the difference? The organic product is same, reactant is same, reagents are different. Here potassium cyanide, here cyanide ion, and the side product is also different. In full equation we are getting KBr, potassium bromide, as a side product. Here we are getting bromide ion. Making a nitrile by this method is a useful way of increasing the length of a carbon chain. So this reaction is very important in industrial point of view. Another reaction: formation of primary amines by the reaction of ammonia. The halogenoalkane is heated with a concentrated solution of ammonia in ethanol. What does it mean? Ammonia in ethanol. Ammonia should be dissolved in ethanol. The reaction is carried out in a sealed tube. You cannot use heat, or you cannot heat this mixture under reflux, because the ammonia will simply escape up the condenser as a gas. Reagent: ammonia in ethanol, reactant bromoethane, organic product ethyl amine or ethylamine, condition sealed tube. Reaction summary: the reaction happens in two stages. In the first stage, salt is formed, quaternary salt is formed. In this case, ethyl ammonium bromide is formed. This is just like ammonium bromide, except that one of the hydrogens in the ammonium ion is replaced by an ethyl group. So when bromoethane react with ammonia, ethyl ammonium bromide is formed. This is an example of quaternary salt. There is then the possibility of a reversible reaction between this salt and excess ammonia in the mixture. Excess ammonia, when react with this salt, amines are formed. So here ethyl ammonium bromide react with excess ammonia, producing ethylamine or ethyl amine, ammonium bromide. The ammonia removes a hydrogen ion from ethyl ammonium ion to leave a primary amine, ethyl amine. The more ammonia there is in the mixture, the more the forward reaction is favored. I hope you understood the topic. Let's try these questions. This question is about a method that can be used to prepare ethylamine. The equation for the reaction is: write the type of reaction, write the condition necessary for the reaction, and what is the role of ammonia in this reaction. Question 2. How to prepare propane nitrile from bromoethane? Why this reaction is an example of nucleophilic substitution reaction, and write the reagents and conditions necessary for the reaction. Good luck. Thank you.